Welcome, everyone. Thank you for joining us today. If you were able to join us last month, you got to see Tammy and Kate give an excellent presentation. That's going to be posted online, hopefully later today or later this week. You can go back and see the part 1 of Blueprint Webinar 101. But today I'm going to reintroduce Tammy and Kate real quickly. Tammy is principal architect within J.E. Dunn's industrial and manufacturing team, where she works closely with design partners from their project's earliest stages, providing input on employee experience, process flow, and efficiency. Kate is senior estimator MEP pre-construction within Holder Construction's design build teams, where she works on mission-critical facilities across the country, specializing in the electrical design trades. So I'm going to turn it over to Tammy and Kate.
All right. Hello, everybody. Welcome. Really excited to have you. I know a lot of you are back for session number 2. So I'm going to go ahead and share my screen, and then we are going to recap a little bit from the architectural and the structural set, and then dive right into MEP. And any of you that are from my region, Southeast region, the best one, we all sound like this because we just got back from Forum and we rip-roared it up. So if anybody else sounds like that, I feel your pain, and this is not normally what I sound like. All right. Hey, Tammy, can you see this? Okay. If y'all have any questions, please put them in the chat. Tammy will call them out to me as we get them. Or if she knows the answer, she'll just type it on up. Okay, sorry, I got a lot of things open over here. Just want to make sure I'm ready for you guys. Okay. Welcome to the MEP series. So the MEP is a discipline of construction processes that address M-E-N-P, so mechanical, electrical, and plumbing. So mechanical is HVAC. So the same way that we talked about architectural and structural responsibilities falls on either the architect or the structural engineer, so too does your MEP set. So your MEP subject matter expert is going to be your mechanical, electrical, and plumbing engineers. They are in charge of this set, and the architect is responsible for the overall project. But this is all about them. Okay, so the same way in the A pages, we saw schedules and legends and keynotes. MEP pages will have the same thing, but they are only about the MEP. Okay, so they're not going to be the same notes that were on the A pages, not the same notes on the S pages. This is your architect saying, hey, contractor, do not forget this. That is them talking to you. So again, a set of drawings or blueprints is a way for everybody to look at the project the same way. So we're going to see a bunch of breakout and viewpoints. So we'll review that here in just a minute. But your MEP discipline are essentially trades that function your building. So nothing is going to operate without lights and power, water, and comfort. So that is what all of these MEP pages are about. Building functionality. How does the building require the need or the future need for the infrastructure that has to go in at what we call the base build? So it's got to be prepped for the whole building, whether it's rented or not. So during the design phase, MEP engineers will maintain a very high degree of interaction with each other. So when they're selecting locations for their equipment, they are double checking with the HVAC engineer, the electrical engineer. Usually mechanical and plumbing are the same, but sometimes they can be different. But they have to make sure that they're not interfering with another installational system. You know, electrical can go so far off that they're not accounting for exactly what is needed for the HVAC contractor, and so to the plumbing. So that can include, you know, breaker panels, plumbing fixtures, HVAC requirements, number of people in your building, usage of the building, type of specific times that your building is going to be at its highest function. All of those are things that are considered in this phase. So just to recap from last session, okay? So we looked at viewpoints. So viewpoints are very important to us. We see them as the way to ensure that all the trades understand how the building comes together. So viewpoints essentially are the architect, structural, mechanical, and electrical engineers giving you a 2D representation of the 3D building. Some things that are or are not mentioned in the MEP plans, I'm just gonna go over all of them really quick. Plan view, so that's your common view that you're gonna see mostly during the set. So I equated it to the dollhouse, right? It is a horizontal slice looking through the building, like as if you dollhouse up and you can, like you're hovering right over top of it. Sometimes it'll look like an X-ray view. Sometimes it'll show you, exact finishes. And then other times it can show you like deep down into the foundation. And that's where you're going to see those dotted lines. But all of those points of view are what we call plan view. You'll also see elevation view. So vertical slice, as if you're standing right in front of the building, as if this is the building and I'm standing right in front of it. I can see exactly the material used, what it looks like, what its functionality, and what it needs. So it gives you a really good idea of what we're talking about within your first, I see it, I know what we're building. So it's a very popular view. Sometimes you'll see it listed as an X-ray. So that's when we can see through the walls. When we were doing the architectural, I think we honed in on the roof so you could see everything from the finishes, the exterior finishes, to the interior drywall finishes, to the steel, to the trim pieces and the metal coping. So again, sometimes it can be that X-ray view, or it can just be what the end product is looking at. The other one is going to be our section view. Okay, same thing, vertical slice through the building, X-ray vision, giving the exterior of the walls all the way from the outside to the inside. So it's just what we just talked about. That's that section view. And then sometimes you'll see a vertical slice through the wall of the elevation view. And what that's giving you, that's showing the layers. That's where your trades meet. Drywall meets your steel contractor, meets your mason, meets your painting contractor, meets your roofer. That's where all the details are going to be. And those relate to your detail views, a different viewpoint. But those are your finite, itty bitty, way trade overlapping. Usually you're going to see this, and that is telling you there's something expensive here or labor intensive. You cannot miss that. That's a lot of times where your money is. So we always want to know what trades we're overlapping with, where they're coming from, and at what point we're interacting with them in the build, because that's when you're going to see up or down with your labor rates. So the more detailed, that's what we called our Where's Waldo. We're like Easter egg hunting. We're playing detective. That's where you're going to use your legend and your keynotes and go and find all those symbols. So you have to find all the details through the plan view, through the section view, through the elevation view, and through the detail view to really understand how this building is going to come together. Because the point of the permit set is so everybody can understand how it goes together, so that we can get as close to our price as possible for the GC and the owner. So that's kind of the point of view where we're coming at. Moving on to MEP. Okay, so your MEP pages host one more, no, just show me. Your MEP pages host another viewpoint. It's my favorite. It's called an isometric viewpoint, and we will see this. It's a visual representation of a 3D object, but it literally will show you what goes underground, what goes above ground, what goes through the floors, what goes through the roof in like one snippet. So you can see everything in the building that makes sense to you. It's the best one. It's usually only found in architectural and MEP. So it's usually plumbing that you're going to see that the most. Other things we're going to see that we found in common are schedules, electrical, MEP, HVAC, plumbing, all have their own schedule. They also all have their own schematic design and drawings. So we'll go back and talk about that. But essentially the schematic design is a graphical illustration that is used to make the viewer understand the function of the building. Okay, that's the why. Okay, why am I doing this? Oh, perfect. Here's a drawing, and it looks just like a drawing, like a cartoon drawing. So it's very helpful. So what you're going to see is that picture is representing the components or the process or the idea of what your symbols and lines mean. So it will depict only the most significant components of the building. And again, you're most likely going to see these through your one line or your HVAC schematics. And Tammy will get into those.
Hey, Kate, and I'm sorry to interrupt. We're still seeing just the title sheet.
Yep.
Okay.
I'm just still going up. Oh, should you see my face? I'm sorry. You probably should see my face. I'm like being expressive and everything. We're not even seeing my face.
No, you're good. I thought you had flipped through to another slide.
Nope. Nope, there's my face. My TV?
Yep, we're good. You're good.
Okay, perfect. Okay. Sorry, I was just letting y'all stare at my stuff. Okay, perfect. Well, I have really expressive situations over there. So what are MEP drawings? So essentially, MEP drawings represent mechanical, electrical, and plumbing drawings for your project. So without your MEP, you don't have any functionality with your building. None of your systems are talking to each other, and you potentially have a very expensive paperweight that you cannot open. But the MEP provides occupants and amenities for a normal day-to-day activity. So that's when we were talking about your electrician, your engineers are going to try to figure out what we're doing, what the usage of the building is, and what the potential future lifeline of the building is, because we do usually like to do that in the initial core and shell of it. So M, mechanical. Most people know it as HVAC. Technically, it's mechanical, but HVAC drawings are simply technical drawings that display information concerning cooling and heating of the space. So the main object of HVAC, which stands for heating, ventilation, and air conditioning, is a system to maintain good air quality given the appropriate ventilation of the usage of the building. So think about an office building doesn't have to have the same as like a gym, right? Where people are breathing heavy and sweating, totally different function. So it's all about your filtration and your thermal comfort is pretty much how we would rely on that. E, that's me, electrical. So electrical provides you with all of your systems tying together. The electrical drawing shows you necessary information for the design and installation of the building. They include power, lighting, communications, safety, control, access. Electrical drawings show the location of your panels, your outlets, your feeds, your lights. Every single teeny tiny thing is on your electrical page. So that's how what those we're looking at, those viewpoints, like we're gonna, dollhouse up, look down, is gonna show us the brain of the building, where it's going, where it's coming from, where it's coming in the street, and entering out. So it can include anything on your page will relate to the plumbing, the HVAC, the lights, the controls, the doors, access doors, like absolutely everything. Your plumbing drawings, what is plumbing? Water, right? How does the water get in the building? How does the water get out of the building? Multiple types of water. We have fresh water, so drinkable water. We have waste that has to go to the street. We got sewer. We have runoff water. So all of that's considered in the plumbing drawing. So it's a system that represents running water for everything from restrooms to labs to waste. Other systems that you'll see in plumbing, gas lines. HVAC has condensate lines. So sometimes your plumber will pick that up because your HVAC machines, like they shake and they are exposed to the elements. We want that to go through. And sorry, I was looking at the chat. Other than that, I'm gonna hit it to Tammy. Sorry, it was a little weird display because I was reading something. I'm gonna go quiet. I'm gonna let you go, and then I'll see you back at the e-pages.
Thank you, Kate. So I'm going to dive in. Hopefully you can all see my screen. We've got the drawings pulled back up. So I'm going to start with a dive into the plumbing, and then we'll jump into the mechanical. So this is our cover page here. And you can see as part of our Where's Waldo, there is an index of drawings, and that gives us our sheet list so that we know kind of what's ahead of us on that road ahead. We can see what information is going to be included in that set for the mechanical, plumbing, and electrical drawings. So the first sheet that we're going to encounter, on our plumbing drawings, let me widen the screen a little bit so we can get a little bit better view, is our symbols and abbreviations sheet. And as Kate mentioned, every set of drawings is going to have a discipline-specific set of symbols and abbreviations. So what shows on the architecture is not going to be the same as what you see on the plumbing. What you see on the individual discipline drawing is what's going to be related to that set. Also very important to note as you're looking at the abbreviations, just because something is listed here on this abbreviation set doesn't necessarily mean that you're going to find it in the drawings. It really works the opposite way. If you see something on the drawings, you're not sure what that abbreviation means, you can come back here and check and look. But again, just because you see it here doesn't necessarily mean it's going to be on the drawings. And then our symbols is really, this is kind of our clue set for the detective work that we're about to do for our Where's Waldo. It tells us what different things are going to look like on the drawings. So we can see, for example, what a floor drain is going to look like, what the graphic symbols are for an emergency shower or for a clean out. And then we can also see on the they'll use different line types to represent the various types of water lines and sanitary lines that are shown on the drawings. Now, when it comes to plumbing drawings, we have, as Kate mentioned earlier, we have plan views, we could have some section views, we could have some details, but I really like to start with the riser diagrams. For me, this is a great way to orient myself to what's going on in the plumbing, because it really gives us that 3D picture of how everything is working together. So if we look here at the women's restroom, for example, we can see on the left here is our sanitary lines. So we see all of our fixtures. We see the sanitary lines, the waste lines that are coming out of those fixtures, and that they're running here kind of to the north. We can also see the vent lines and what's kind of going on overhead. Code requires all of our waste lines to be vented. So we can see how the designers are planning to accomplish that. And then on the other side, on the right side here, we can see our domestic water. So we can see where all the supply is coming to those fixtures, where all the water's coming from, and what size those water lines are. So again, these riser diagrams are just a really good, just kind of quick orientation to how everything's working. Now, typically your sanitary, your waste is going to be run underground, and your water supply, all of your domestic water is all going to be run overhead. So one of the first plans that we're going to look at then is our underground. This is our sanitary waste. So this is under slab. So we can see everything that's coming down and going out the building. Now, in this case, this is our women's room again. So we can see this is exactly what we saw in the riser diagram. If we go back to that for reference. Oh, there it is. We've got our waistline. We've got a 4-inch waistline. You can see this line here collecting our floor drain. And when we go back to the plan, that's exactly what we see in plan view. So again, that 3D view is just a really good way to get oriented. Now, a couple of things you may notice on this plan, as the lines connect, as they feed from the branch lines to the main lines, you will see the lines getting bigger. And that just makes sense. If you think about it like our streets or our map, as arteries kind of feed into main lines, those lines have to get bigger to handle more volume. So you'll see your branch lines are typically going to be smaller than your main lines. These are all labeled as well, so we can see the sizes, 1.5 inch, 2 inch. Again, if you're not sure what of course that means sanitary, but I know that because I went to look at my abbreviation sheet. So don't forget to go back to look at that. Now, so some important things to note. You'll see there's a note here. So even though we have some general notes on our abbreviation page, it's not uncommon for designers to have page-specific notes. You don't try to say that 3 times fast. Page-specific notes. So do keep an eye out for those. And you'll see those listed on each sheet that they apply to. So in this case, our note says, for continuation of storm drainage and sanitary, refer to the civil drawings. Now, that's an important thing to know about the distinction of responsibilities. So the plumbing engineer is going to be responsible for all of the water and all of the waste within the building up to 5 feet outside of the building. Once you get past 5 feet outside of the building, then the civil engineer takes over. So you'll find the rest of that information on the civil drawings. So where it goes from the building to the street, that's going to be on your civil drawings. So again, the plumbers for us is just making sure that we know that is where that continuation of that information is picked up. So our next drawing then, and the plumbing engineer has done a really nice thing for us here, where they've created 2 separate plans, one for everything that's below the slab, and then one for the vent lines. So this is still relating to the sanitary. You can see it's our waste. Now this is our vent floor plan. So this is all the vent lines that are running up above. Again, we've got some page-specific notes. I have to slow down on that one. We have some notes that are specific to this sheet, so don't forget as you're going through sets to be keeping an eye on those. There's often very specific information related to a key component that you won't find elsewhere in this, so don't ignore those for sure. Now you'll also see, and I don't know if you caught it on the page before, we have a big 6-inch drain, and we could see that, I think, here on our sanitary plan underground. So what is that? It's not a vent line. It's not dashed. It's not shown like the vent lines, but it says it's an overflow storm. So that storm is my first clue that maybe that could be related to some roof drainage. And if I go to the roof plan, sure enough, I can see we've got some roof drains up on the roof. It looks like we have 2 on this particular plan. So when you have the roof drain, you're typically going to find some kind of overflow related to that as well. If this roof drain gets clogged up, the water's got to have somewhere else to go. The structural engineers don't typically design the building to hold all of the rainwater that could possibly collect. So there's usually some kind of relief. This could be a scupper through the wall. In our case, we have an actual overflow drain. So we have a secondary drain, which is what we saw on that plan before. Now, another very important distinction in responsibilities, the plumbing engineer is responsible for the roof drain and overflow drain design. Now, if we had gutters and downspouts instead, that would actually be the architect's responsibility. The plumbing engineer does not actually size gutters and downspouts, only roof drains and overflow drains, only things that actually need to be piped through the building. So important to note, if you have gutters and downspouts, you'll go to the architectural drawings to get that information. And then finally, we have our domestic water plan. So these are all the lines that are running overhead, bringing water to the various fixtures. Again, if we go back to our women's room, and we can go here again to reorient ourselves, we can see that everything's running overhead and feeding to the individual fixtures. And in our plan, of course, that's exactly what we see. There's that main line and all the branches running down to those individual fixtures. Again, these are all labeled with their sizes, and we can go back to our symbol and abbreviation sheet to see what DCW or DHW, what those mean. If we come back over here and we go up, we can see, interesting. This would be a good RFI for your plumbing engineer because they didn't have it on here, but we know that it's a distribution. And there may be, there is not an individual legend. We do know that this is typically domestic cold water or domestic hot water. So it could be that that's a common term and they didn't include that abbreviation, although I'm going to bust on that plumbing engineer because they should have. But again, we've got some specific notes to this sheet, so keep an eye out for those as well. And finally, schedules. Kate talked a little bit about schedules. So a schedule is going to be your very, very, very detailed information on a single specific building component. So you can see here we have plumbing fixtures. So in this case, we've got designations that we can refer back to the plan to see where they are. It tells us what type of fixture it is. It's a sink or a water closet, what the line size, what type of water it needs, as well as what type of sanitary line, what size. And then it gives us our fixture units. Now, this is a code specific requirement that's usually kind of a weighted, it's a weighted number based on the actual water usage that fixture will encounter or will see. So your mop sink, you're going to have a lot more water than, for example, a hand sink. And you can see your water closet will have a lot more water usage than a hand sink. So these weighted averages are what the code officials use. So important that the engineers have to include that information. And then on our remarks, we can see they actually have the specific models designated with some additional information. So our pre-construction team can price them accurately, and our trade partners can purchase and procure that equipment accurately. And you can see any type of equipment that is included in that plumbing system is going to be here on this schedule. Now, jumping over to the mechanical set, again, we can see same kind of orientation. So we have our symbols and abbreviations page, and you can already see, I think, just at a glance, that this looks very different than the plumbing, because these are very specific just to the mechanical set. So we have our abbreviations here and then various symbols. So we can see how things are going to be tagged, how they're graphically going to be shown, and what some of our tags are going to be telling us, what kind of information they're going to be giving us. Now, when we look at this plan, now this one looks probably a lot more confusing. There's a lot more going on here than our plumbing plan. And I would encourage you, as you're working through these and as you get to some of these complex plans, is just break them down piece by piece. So really make sure that you allow yourself a lot of time to work through these drawings and look at kind of each piece and work through it. And you may also, because you're going to be referring back to that abbreviations page a lot, also, another good tip may be to have 2 Bluebeam sessions open side by side, so you can have that abbreviations page that you can quickly refer to, as well as your plans that you can be tracking down the information. Now, I like to start on the mechanical plans. I like to start with where everything is coming from. What's the source? So our plumbing and our sanitary plans showed us, where the water is being distributed through the building, where the waste is going through and out of the building. Our mechanical plans are showing us how the air is moving through the building. So again, I like to start with the source, and that's typically going to be with your rooftop unit. So this is your large equipment. You've seen it as you've driven by buildings, your large equipment that sits on the actual roof. And this is what brings air in. It will kind of condition it, start to treat it, and then start to distribute it through the building. So you can see here, it's kind of in this general area. So keep an eye on that, because as we go back to our plan, we again can look and say, okay, so we know our rooftops are in this general kind of area. And I can see that because I can see here, I've got some ducts that look like they're kind of going nowhere, but my label says they're going up. So I know this is my source. This is where that rooftop unit sits. This is where the air is starting to come down through the building. Now, if y'all have ever done any of those puzzle books and done the mazes, this is exactly the same thing. So as you're playing detective, all you're really doing is starting at that source and you're going to trace it through. So as an example, I'm going to start tracing this through. So I know this is my source. I know we're going this way. Now I have a duct that's coming off and branching off. I can trace it down. Got a little something that's going on here, looping back around. So you can already start to see with the ductwork, there's a lot going on overhead. You've got all that piping we just looked at. Now you've got all the ductwork. You've got it coming and layering on top of it, feeding back over itself. So kind of a tangled web up there. So very important, the coordination for the designers is really critical to make sure that there's enough clearance for all of this stuff to do everything that it needs to. Now, as we're tracing this down, we can see we've got some labels. So we know we start 20 by 20. Now we're coming down, we can see it's a 14 by 14 duct. So again, as we're starting to branch off like the plumbing did, we're starting to get smaller. As we come down here again, we're now coming to a 10 by 10. And now we come to another piece of equipment. It's a PFB. What is a PFB? Well, we can either look at our abbreviation sheet, or in this case, we know because we looked at the symbol sheet that this is actually an equipment tag. So we can come to our schedule and we can look for PFB. Here we go. So here's our PFBs. So these are parallel fan powered boxes. And I'm not even going to try to say that 3 times fast either. So if you don't know what this type of equipment is, and I would say if you ever encounter anything on a drawing where you don't quite know what the system is or what the equipment is, don't be afraid to just go and Google it. So we know that this parallel fan powered box, this is a box that's up in the ceiling that the air runs through, and it conditions the air to a specific temperature for everything that's coming after it. So you can see all of these rooms are going to be set to the same temperature because they're coming out of this box. Now, mechanical designers like to do that, and I think it's a great idea. If you've ever been in an office and the guy sitting next to you wants it at 60 degrees and you are absolutely freezing, and then over in the break room, it's burning up because the sun's blazing through the window and it's 80 degrees. This is where these types of systems are really beneficial because you can control a specific room or a specific environment separate from everything else. So in this case, your reception area where you've got a lot of people sitting might need to be a different temperature than your operating rooms. Your operating rooms may have a little cooler. So you're able to do that with this type of equipment. And again, we can go back to that schedule and we can see exactly what type of equipment that is. So as we're tracing it down, now we're coming out, now we've got some 8x8s, and then we terminate at our diffusers. Again, we can go back to our symbols page. We know the box with an X is a supply diffuser, but we've got a tag here. So let's go and see what that means. So if we come back to our abbreviations page, again, we can see here our box with an X is a supply air diffuser. And our tag down here says this is an air device, which a diffuser is an air device, and it gives us our CFM. So that's our cubic feet per minute. That's how much air is blowing through. So if we go back to our plan, we can see we've got an A1 105, and now we go to our schedule, and we can start to see how all these pieces kind of fit together because here's our air device schedule. We've got our A1, and now we can get really detailed information about that one specific diffuser. We know it's a supply diffuser. We know it's a 24-inch by 24-inch. We know the manufacturer. We know the model. Now we've got really specific information on that one specific thing. So you can start to see how often you're going to be flipping back and forth between these sets of drawings. And again, I just really encourage you, don't be intimidated by this if it looks confusing because there is a lot going on. Just break it down piece by piece. As we follow this one particular system all the way through, then we can go to the next one. So we go up, we know we're crossing over something. Now we've got a 16 by 14. We come up here, look, oh, here's another fan box that feeds now this area. So we can kind of track this down. We can look at our air devices here. We can see our duct sizes here, and then we can just keep moving on. So as you look at this as a whole, you can start to see how the pieces kind of break down. And again, final thoughts on the mechanical. Again, just allow yourself a lot of time to be able to work through this. And Kate, I'm going to go ahead and turn it back over to you and let you start running it through the electrical. And you're on mute.
Life's hard here in the quiet office. Okay, guys, sorry. Hi, yes, okay, back to electrical. So I'm going to share my screen in just a minute, but I got a private message who wanted me to tell about wires and conduit really quick. So I would love to address that. Yes, people don't know if they're not told, right? And you don't know what to look out for something unless you talked about it. So Conduit is essentially a pipe or a tube that protects and routes the wires in a specific way that protects them from being nicked, dinged, or spliced, that can actually cause a fire. But essentially what we're looking at when we're talking about conduit, it's either going to be metal or plastic in commercial applications. And most conduit is rigid. You can bend some of it, but you'll only see flexible conduit when it touches the HVAC systems that Tammy was talking about. So anything that like rattles and shakes, like that's going to get a flex or flexible metal conduit that will allow for that like percentage of shaking that that equipment is designed to do. Okay, so what are wires? So there's essentially, we're just going to work on three, okay? There's a hot, a neutral, and a ground. A hot wire carries the electricity from the panel, from the power source to, let's say, a light fixture or a receptacle or an outlet. And we call them outlets. We don't call them outlets, we call them receptacles. Also, we don't call conduit pipe. We are not plumbers. This is not Mario Brothers. We call it conduit. So it's very different. But essentially, yeah. So that's actually carrying your electricity. That's your hot wire. Your neutral wire takes an unused electrical current and sends it back to the breaker. So say it's allowed for like 20 amps and it's only pulling 0.0002. That's all it needs. Lights are smart these days. Switches are smart. Receptacles are smart. It's great. So it's giving that extra power back. So that's neutral, okay? And your ground wire transfers your current away from the device if something goes wrong. It is your fire alarm system. It goes, eek, hot. Crushes the light. Nope. Stops the breaker. Stops anything. So, you know, you got your hair dryer going and you are using the dishwasher and your circuit breaks. That was saying, oops, too much. That is your ground wire working. So it's a system that is directly attached to the earth that can take your current away from a device or a system for safety. So it'll take it from the equipment and then it'll cut it before it even gets to the electrical source so it doesn't damage the panel as well. But in order to do that, it's grounded to the ground. So same way lightning strikes, you want to get in rubber shoes and hop onto piece of ground. Same thing, ground wires doing the same thing. It's just connected to copper wires underneath the earth. Okay, so I'm going to share my screen and I'm going to actually like show you what I'm looking at. So apologies earlier, but you know, it's all done. Okay. Tammy, can you see this?
I can.
Perfect. Okay, guys. So these are your electrical. So same thing that we talked about when we mentioned the architectural drawings. So this is one that literally I will snip it and put it right at the corner, or I'll save it onto my desktop so I can do it. Or I print lots of paper. So I do 11 by 17. Sits on my desk. I know exactly what it is. So it's showing you a symbol and telling you what it is. So these are your Easter eggs. These are what we are hunting in our Where's Waldo. You see a dollar sign, not money, that's a switch, but the letter indicates what it's controlling. So that will, you know, just a little controls. So same thing. These will be your light fixtures. These will be your industrial light fixtures, wall fixtures. So all we're doing is hunting symbols. I'm also going to look at anything, and then, you know, they got power symbols. So junction box, I like to think they're like half hashtags in a circle. That's a double receptacle. That's like a standard outlet. That's where you got, you know, 2 ports there. And then it shows you some mechanical items. But what I'm really interested in is notes. Read the notes. The notes is the engineer saying, hey, don't forget this. It's super, super, super important. And if you do miss it, very likely it's going to be on your dime. So we don't want to do that, right? And then we have abbreviations. So these abbreviations, same as the architectural, may or may not be used in every set. But if you see it, okay, got it. So, and we will see some of those. So I'm going to get in. Okay, so we got a couple minutes. So I love electrical, guys, because I can see the whole site, right? Okay, so think about, so this is the entire site. So there's obviously existing buildings around. What else can I see? Parking lot. What else can I see? Trees. And then I see these little, OPI, OP1. What is that? Okay, well, I know that I looked on my symbol sheet and it is a light pole. So it's gonna show, these are, we call them daisy chains, they're little hops, little scallops that you'll see like along. It just means that it's touching multiple things before it hops back to its source. But what we're really looking at, so this is, again, your dollhouse version, right? Horizontal slice, I'm looking, staring into it. And I don't see any of the finishes, which is fine because it's overview. What this is showing me is where the power is coming from. Georgia Power, Duke Power, or Duke Energy, if it's coming directly from an up above ground transformers or on the wooden poles, or if it's on one of the big green transformers that sits on a pad outside your building. So that's going to tell you where it's going. So it's somewhere in this site. This is here, and it says utility transformer. And then number 2, that goes underground. And it goes into my building. And here we go, above slab or below slab, but it's gonna go through the entryway into this one room. So that's very likely your electrical room. So I'm like, oh, okay, these are boxes that I can see. So I know that this is my electrical room. So this is where my main power distribution goes. All the power from Georgia Power, Duke Energy sits right here. And in this room is where it's going to what we call branch off. I'm gonna go hit some lights. I'm gonna go hit some receptacles. I'm gonna go hit a fire alarm system, okay? So everything starts from this building. So all that is showing you is, hey, this is a site. Okay, I've got some site lighting. Cool. Let me go look at my site lighting schedule. And then other than that, I'm looking at where the power source is. And again, we're gonna read keynotes. We love these keynotes, guys. To the building, how it penetrates into the building, where it penetrates into the building, and then where my electrical room. Other than that, that's all I'm doing on this page. That is all this page is telling you. It is just giving you essentially a vicinity of where we are going. And then same thing, architectural, it'll show you a roof plan. So this is a roof plan as if I'm a drone going over the building. So this is actually what the roof looks like. And then I can see it's telling me, I see RTU, so rooftop unit. That's an HVAC thing. But I'm like, okay, electrical, I have to, what we call it terminate. We have to bring some source of power so that it can function the way that it's designed to. I also see ACCUs, don't worry about that right now. And then I see 2 keynotes. I'm like, okay, go find keynote number 2. Ground base of steel column. Great. So it's telling me I've got to ground through that steel column. So again, it's just a note that I'm looking at. And then I see another little note. Remember we talked about that grounding? Your grounding actually, for that ground wire, actually goes around the whole building and then away from your building and then loops again. And the reason that it does that, so you'll see these little dashed lines, this is actually your grounding. These 2s and 3s, those are the copper, goes 10 feet in ground. And then you'll see a separate loop, and that is a security loop. So if lightning actually hits your building, even if you don't have lightning protection, it's going to travel through those copper and into these loops to protect everything in the building. So electrical is all about our backup, right? We don't do anything without lights or power, and we all need lights and power. Okay. There's 3 types of drawings, and I'm getting a little close on that. So there's 3 types of drawings. There's power, okay? So that's gonna be your receptacles, your how we're tying in. So like the bathroom, this is our little women's restroom, and I can see this one of those little hashtag things. So that's gonna be a receptacle. So I'm gonna go and hunt all these. Like I'd be like, oh, what is that? A J in a box. Okay, well, I know it's a junction box, but it will be shown on your symbol pages. I also see some notes here. There's a weird shape. Again, I go look at my legend, and then I go check note 7. What's note 7 say? Coiling door motor. Okay, Mr. Engineer, Miss Engineer is saying, hey, there's an extra component that if you don't get this, sorry for you. So they're calling it out specifically for us. So This is our power page. Mostly what we're gonna see is our mechanical tie-in and power, like receptacles, devices, teledata outlets, right? Like any junction boxes that could be for future cameras. We don't really know. You have to go and hunt the keynotes there. Next one you're gonna see is your equipment. Okay, so equipment is different than your power. Equipment is supplied by others like our mechanical contractor, but we have to do that termination. We have to make it function. So we have to do the wiring in the conduit plus a device or a switch, which we usually call disconnects, where it literally has to turn on and you physically can turn it on or off from one point. But that does not mean it's not necessarily provided by the HVAC contractor. So you got to check your notes. So that's also what we're seeing. We're seeing junction boxes, and again, it could be for future. So there's something, and it's got PFB. So that's that pull fan box. And it's saying that it's 2-1. That's a name. Sure, whatever. I don't know why they name weird things. I'm just happy it's not long. No, because we have typed that in. But what we're also always going to see is here's my electrical room. So here are the panels, and this is where everything is going. So when you're trying to figure out your run and you put your scale in, you're like, I'm going over here, I'm going right there. Or you can do this, but we're estimators. So we go the worst, longest way possible because you never know what's going to be in the way. All right, the other set of drawings that you're going to see is your lighting plan. Okay, so here's your lighting plan. And you notice how I used to be able to see these operating chairs and now I can't. They're kind of light gray. That's saying that something is in the way of it. Something's above it. So again, if I'm dollhouse open, looking at that horizontal slice down, I'm going to see a light before I see this chair. So these are light fixtures. You're going to count. Click, 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 click. And then you're also going to see on this lighting controls. So a lighting control is your switch. Your occupancy sensor, this is a sensor in here. So the minute I come in, it's going to turn on. But again, it's not going to run all day. So, you know, ours close it at 8 p.m. so that it stops, it saves its power. And then you'll see other ones. So this is a, you know, not money, the switch dollar symbol with an LV. So you go to the legend and be like, where's LV? Low voltage. And then it's got keto too. So again, I'm hunting notes. 2-button low voltage override switch. Those 2. So I turn it on and I can turn it on, but it's also going to turn on automatically if somebody walks in the room, right? So it's telling me what it's controlling. So again, we are hunting notes, we are hunting Easter eggs, we are playing detective. And same thing here. I'm going to see the electrical room every single time because it's telling me this is your source of power. And then other than that, you're just finding and clicking. So this is a light type D1H. It's a little downlight. That's different than your exterior, we call a wall pack that sits above the wall, below the roof, that points down for security on your sidewalks and your parking spaces that are around the building. So you're just going to go and hunt all of these. Are there any questions so far? Because I'm going to move on to the one line if there aren't, just so y'all can see what it is. But put them in the chat and Tammy will read them. All right, so same thing here. We have special systems. So special systems may or may not be in your electrical page. Okay, so special systems sometimes will have telco pages, T pages, fire alarm pages, or this is telling me it's a special system in my E pages. So I'll be like, oh, what is it? So it's a little S with the cross. So it is a sensor and it is actually fire alarm. And now all of a sudden, look, I see this hallway, but I didn't see on another page. I'm like, oh, where's the hallway? It's an existing building. It's shown as dark. So Tammy talked about that in the last session. That means not in contract, but there's something happening between here. So my guess is it's the same fire alarm system for the same building in the new building. So it's a tie-in point, but I don't know that. But then Oh, I see some dashed lines. You see dashed lines, something's there. It's telling you something is important that's right there. So again, like, let's look at the restroom, women's restroom. So we can see the restroom. When we see the sensor, it's black versus the gray below it. So it's saying it's on the ceiling, so it's above. And then same thing here, we got some sensors for the fire alarm. Again, you're gonna do your fire alarm, contractor is gonna pick all of this up, but electrical, here's the nugget, guys. Your electrical, here's your electrical panel, here's your fire alarm panel, lighting panel. But who runs all the conduit? We do. We do. So the fire alarm guys, he's just providing that itty bitty little wire, and don't let him tell you that he needs a 3/4 inch, because he does not. He has a tiny, teeny, tiny baby wire, and he's gonna go and connect all of these. A lot of fire alarm these days are remote, so they don't even need a ton of hookups, but I have to pick up the conduit because it's gotta go in the wall, through the ceiling, through these points to touch all of these. So I need to pick up a plastic or a light gauge metal or a heavy gauge metal pipe that we call conduit, specifically designed strapped to the ceiling that goes above all the ceiling panels, the ACT ceiling, acoustical tile ceilings that we see. So all of that, but I have to make sure I pick that up. On top of that, I need to make sure that anything that's on the wall, I've left a box for. So remember we saw on the power plans, we saw those J's in a box. That was prepping us for this page. So I'll be like, oh, okay, so I have a fire alarm device on the wall. What else do I have on the wall? And you're just walking through it. I'm just walking through. There's one, it's in the vestibule. It's where people walk in. That makes sense. So somebody can hit the pull station. I'm just walking through the building. And I'm gonna walk through this building about 9,487 times while I look through this whole bid set. But I will tell you, I will not miss a thing, and I know what it is because I'm checking my keynotes and I'm looking at my viewpoints, and we're double checking all of the schedules. All right, 12:51. I'm going to talk about the one line really, really quickly. So what your one line is, it is your full site, full building in one line drawing that tells you what to where. Okay, so I'm not going to do any other grounding. We're just going to look. Georgia Power, utility transformer, Duke Energy, Georgia Power. Okay. Then I hit something, utility transformer by electrical utility company. So who pays the bill? Who brings the building? Okay, so that's the company that you pay your electrical bill. That's on them. Okay. Then I've got this little M, so I would go and find that meter. And then I'm going to see these little designations. So this is main. And I've got a schedule here. It's a feeder schedule. So your feed is your main line, okay? The main source of power. Then you're gonna little branch offs based on where your lights are. So it's telling me I've got, this is main, 4-inch conduit, 4 350 is wire size, don't worry about it right now. 2 sets. So times 2. So 2 4-inch conduits with 4 350 wire inside of it, going from, and I'm going to look at the main, going from this utility pad transformer to our main distribution panel. So the main gut panel, the big panel that's in there. And I'm like, oh, okay. It doesn't say if I'm going above ground or below ground. Well, that's where we got to think about it. And we're going to look at note 2. Feeder to be installed 6-way concrete duct bank, so that's below grade, with 4-inch conduit and spec carriers. So that's saying it's underground. So it tells me exactly where it is. And then other than that, so this is that main distribution panel. So this is in that electrical room that was shown on everything. These are your main feeds. So it's branching off to whatever these things are. So you're just like chasing all of this. And I like super ran out of time, and it's because I made my entry way too long. But we're also going to look at, so same thing, A pages had door schedules and finish schedules. We have a light fixture schedule. So I'm just looking at the name, 4-inch downlight, blah, blah, blah. You send that to your supplier and they do that. So I'm not super worried about that. unless I see it gets like alternate, so I would just reach out to those people, but don't worry about that right now. And then lighting controls, same thing. How are we controlling the lights? So that's those occupancy sensors that are gonna hit the minute you walk in, but it also has 2 park controls, and then an equipment schedule. So all this is saying is, so the RTU, rooftop unit. And all this, blah, blah, blah. I don't care about that. I'm looking at your wire and conduit. So it literally tells me what it goes from. So 1 1/4 inch conduit, 3 number 6s, and 1 number 10 ground. It's going from MDP to, and it'll tell you the panel, the Y. I don't really care about the Y right now. But like, so it'll give you kind of the circuitry information. But what you're really looking at is what your electrical contractor is really looking at is the wire size. So that we don't have to calculate it for us, because that really is the engineer's job. And I'm super running out of time. All right, Tammy, I'm gonna unshare my screen. Somewhere, wherever it is. There it is. Awesome. I'm so. It's fun though, right? Great. So hit us up with questions. I know that was a lot of information, and MEP is one of the most technical trades. So we say born in the trades because you get it or you don't. It's really, really complicated. But what it is, you just read the keynotes, okay? Find the symbols. I literally like highlighter and a clicker, and I'm just like rocking out to like death metal, and I'm just clicking and noting, and I'm reading keynotes. Like, and it's very sequential. Nobody is trying to trick you, okay? Blueprints, your architect wants it to be as easy as humanly possible, and that's why all the information is there. Nobody wants to trick anybody, so it's not a test. And you know what? We're not in school, so go ask your neighbor. Hey, Mr. PM. Hey, Miss Superintendent. Hey, Lolene Mitchell. Hey, Tammy, I don't know. I'll tell you. I get that all the time. Let's go. Let's go. So yeah, y'all can come off if you want to. And you know, happy to hear a voice, or you can write in the chat. Or I guess I should share my screen for our final slide, right? Oh, Tammy, will you share the screen for your final slide? You can.
I can do that. I can do that. Let me pull that over. So this
Thanks,
has.
Ashley. Yeah, I wasn't too much, but if y'all do have questions, Tammy's gonna put up our email and our LinkedIn, so y'all come and find us, and we're happy to help in any way that we can.
Here we go. Well, we'll just ignore all the stuff to the side. But our emails are here, QR code. So definitely don't hesitate to reach out. We are happy to answer any questions that y'all have. And thank you all so much for attending today. I hope this was helpful. Like Kate said, I know it's a lot of information, but just, you know, allow yourself that time to just work through it piece by piece. And that's how you eat an elephant, right? One bite at a time.
That's right. Thanks, Michelle. All right, we'll see you later, Melissa. Y'all have a great time. And what up, girl? She's from my chapter, Atlanta, 49. Thank you, Lolene. Appreciate it. Okay, y'all hit us up if you have anything. And if not, go crush the week. And my throat hurts because we had Southeast Forum and we crushed it. Ashley, you should be able to send a link to. I'll get it for you. All right, Carla, thanks.
All right. Thank you all.